Hi everyone, my name is Will and we're going to be going through some past WGEC exam style questions. So for question 1, we have to write an account of the industrial process from the exam paper and include the name of the separation method, what crude oil is, and a description of how crude oil is separated. So as you can see, I've separated, colour-coded the 3 main points in the question, so the separation method, what crude oil is, and how crude oil is separated. So normally on exam paper I like to do little arrows and summarize what I'm going to write. So the separation method is fractional distillation. So the crude oil is basically hydrocarbons, and crude oil is separated. So there's a few little key points. So vaporization, gas goes up the column, and about the boiling points. So these are little key words that you should include in your answer. So an example answer here is crude oils are mixtures of different hydrocarbons. So that satisfies the first point, which can be separated by fractional distillation. So here you have said what the separation process is and what crude oil is. Then you can say for how crude oil is separated. So the crude oil is heated and vaporized before entering the column. Smaller hydrocarbons with smaller lower boiling points will rise in the column and condense higher up in the column. Longer hydrocarbons with higher boiling points condense lower in the column, and hydrocarbons with similar boiling points condense at the same level in the column. So for question 2a, we need to explain why it's possible to separate crude oil using this process. When talking about separating crude oil, you always have to think about the chain length and the boiling point. These are the key words that need to be mentioned in these answers. So for the first mark, you'd have to have said different hydrocarbons have different chain lengths. And for the second mark, you'd have to have said that different length hydrocarbons have different boiling points. And as a result, these can be separated by this. For question B, we have to basically discuss about cracking and state how the process is carried out and explain why it is important. So as I always like to do, I like to put little arrows and suggest little keywords. So this can be carried out by catalysis and by breaking large molecules, and it is important that you can get useful hydrocarbons or fuels and there is less waste. So an example answer you can have is cracking is carried out using heat and a catalyst, so you get 1 mark for that. Cracking breaks down large hydrocarbons, which are less useful, into smaller useful ones. This increases the amount of fuel obtained from the crude oil. It produces monomers which can be used in making plastics. And therefore you could also say you can get a profit from this and or less waste for the 4 marks. For question 3a, we need to have stated what is meant by a hydrocarbon. So a hydrocarbon are compounds that contain hydrogen and carbon only. So you need to mention that they contain hydrogen and carbon. So for question B, we have to say why it is separated. And as I said earlier, separation is also always due to the boiling point or the chain length. For question C, we have to answer the following one. So we need to name the process in order to produce these small molecules, and that is by cracking. For question CII, what is the process to make these plastics? And this is called polymerization. So for question D, we have to use the ethene molecule and see how we can produce polyethene. So first of all, we need to break the double bond. So we break these double bonds into single bonds. As a result, these can join together to form longer chains through polymerization. And finally, for question E, we need to give one disadvantage of using plastics such as polyethene. So you could have said that they're non-biodegradable, they increase the use of landfill, or they produce harmful gases when burnt. You can get 1 mark for saying any of these. For question 4a, we need to name the 3 elements that must be present in the coal to give the product shown in the table. So as you can see from the table, we have carbon dioxide, which is CO2, we have sulfur dioxide, which is SO2, and we have water, which is H2O. As you can see, in all of them, there's oxygen, therefore, in the coal, there has to be carbon, sulfur, and hydrogen. For II, we have to state what finite means, and this is fuel that can't be replaced or fuels that will run out. So for example, if you put coal in a fire, and when the fire goes, there's no coal left, so think about it in this terms. So for BI, we need to balance the following equation. So normally I like to draw little lines, little diagrams. So we have 2 x's and 2 lines on the left, and we have 2 x's and 1 line on the right. So now let's balance these. So we need to balance the oxygen, therefore we need to times the water by 2. As you can see here, there's now 4 hydrogens and 2 oxygens. Therefore, on the left, we now need to balance the hydrogens, so we times the hydrogen by 2. Therefore, the overall equation is 2H2 plus O2 goes to 2H2O. For BII, we need to state the chemical test for hydrogen gas and give the expected result for 2 marks. So for this, when you want to test for hydrogen, it produces a squeaky pop noise when tested with a light splint. Then finally, for III, we need to give two disadvantages for using hydrogen as a fuel. There are always two. Storage is a massive problem with hydrogen because of its explosive nature, so you can get that for 1 mark. And for the other mark, you can say that large amounts of electricity needed to produce hydrogen. So for question 5a, we have an unknown alkane labelled X, and it was found that it contains 9 grams of carbon and 2 grams of hydrogen. And we need to calculate the simplest formula for this. So from the question, I always like to, for these sort of questions, I like to fill out a table like this, so moles, mass of Mr. So firstly, we can fill in what we know. So we know the mass of carbon and hydrogen, and that is 9 grams and 2 grams. We also know the Mr, which is 12 grams per mole for carbon and 1 gram per mole for hydrogen. Then for moles, how do we work this out? So moles equals mass divided by Mr. So for carbon, it will be 9 divided by 12, and that's equals 0.75. And for hydrogen, this will be 2 divided by 1, which equals 2. So at the moment, we know there is 0.75 worth of carbon and 2 lots of hydrogen. But however, for carbon, we don't like half numbers, we like round numbers. So we can multiply it by 2, but that means we have 1.5 worth of carbon and 4 lots of hydrogen. So therefore we can double it again, and as a result we get 3 carbons and 8 hydrogens. Therefore the simplest formula would be C3H8, because there are no halves or fractions or decimal points, they're all whole numbers. For question B, we need to calculate the percentage by mass of carbon in butane. And this is an alkane which consists of 4 carbon atoms. So butane is C4H10, and we need to work out the amount of carbon in this. So carbon has a molecular mass of 12, and we have 4 of them. Therefore there's a 48 grams per mole mass of carbon. And let's work out the number of hydrogens. So we have 10 hydrogens, and that's worth 1 each. So we have 10 grams per mole. Therefore the total of this is 58 grams per mole. And now we want to work out the fraction of carbon in this. So therefore, the mass of carbon is 48 divided by 58, because we're doing a fraction. So the amount of carbon you have divided by the total mass of your butane. So 48 divided by 58 times by 100, and that gives you 82.76 or 83% worth of carbon in your butane. So for question 6a, we need to complete the table below. So for the first box, you can see we have to name the name of the alkane which has 1 carbon. So as we all should know that 1 carbon with 4 hydrogens relates to methane. For the next bit, we have to write down what the molecular formula is for propane. So you can see from the structure formula that you can see there are 3 carbons and 8 hydrogens. Therefore it's C3H8, or you can use the CnH2n plus 2 rule, as you should know that propane has 3 carbons. And finally for butane, as you can see there are 4 carbons and 10 hydrogens, therefore you should get a structure like this. For question B, we need to name the following structures. So for structure A, you can see there are 2 carbons, therefore it has to be ethan of some sort, and you can see that the functional group is an alcohol, therefore it's ethanol. For structure B, the longest chain is 2 carbons, and as you can see it's an alkene, therefore this has to be ethene. For structure C, you can see that the longest chain is 3 carbons, therefore it has to be propan of some sort. As you can see here, it is an alkane, therefore it's propane. For structure D, you can see that the longest chain is 3 carbons, therefore it's propan of some sort. And you can see that the functional group is an alcohol, therefore it's propanol. Or it could be propan-1-ol because the alcohol functional group is attached to the first carbon. And finally, for structure E, you can see that the longest chain is 3 carbons, and that it is an alkene, therefore it's propene. Or you can write prop-1-ene because the double bond is attached to the first carbon. For question 7ai, we need to use the key to draw diagrams to represent nitrous oxide. So the formula for nitrous oxide is N2O, so therefore there has to be 2 nitrogens and 1 oxygen. Therefore we can draw 2 dots, 2 black dots and 1 white dot. You can either have them like this, so black dot, black dot, or black dot, white dot. Therefore II, we need to use the key to give the chemical formula for the molecule. And from the picture you can see there's 1 black dot, and this is surrounded by 3 white dots, 3 greyish dots. Therefore this has to be NH3. So for question B, we had to use this box and answer the following questions. So for BI, we need to choose 2 elements. So an element is something that has one chemical symbol or 1 element. Therefore this can be hydrogen or neon, so He or Ne, or you can use O2 because this is a diatomic molecule. So for II, we need to choose two compounds. So compound contains two elements. So this can be CO2 and CH4, or you could have said SO2. So for question C, we need to answer questions relating to the chemical formula for nitric acid, HNO3. So for AI, we need to say how many nitrogen atoms there are in the formula. As you can see in yellow, there's only one hydrogen, therefore the answer for this is 1. Then for II, we need to give the total number of atoms in the formula. So there are one hydrogen, because there's one yellow, there's one nitrogen, because there's one N, and then there are 3 oxygens, as there's 3 O's. Therefore 1 plus 1 plus 3 is 5. And that gets you 1 mark. Now for question D, we need to answer questions based on ions. So for Di, we need to give the formula of the positive and negative ions in the compound MgCl2. So MgCl2 can be separated into Mg2 plus ions and Cl minus ions. Therefore, Mg2 plus is the positive ion and Cl minus is the negative ion. There are 2 chlorine ions because chlorine ion has a -1 charge and a magnesium ion has a 2 plus charge. Therefore, to neutralise all the charges, so Mg2 plus 2 Cl minus, so you have 2 plus from the magnesium and 2 minuses from the Cl, that gets you overall charge of 0. Therefore, DII, we need to give the chemical formula for sodium hydroxide. So sodium has the chemical formula Na+, and hydroxide ion has OH-. And because the charges are 1 on each, so there's 1 positive from the sodium and 1 negative from the hydroxide, the charge is balanced, therefore we don't need to add any more. Therefore, the balanced chemical formula is NaOH. For question 8a, we need to describe the triangle. So these are the 3 factors needed for a fire to burn. Or you could say, if you want to remove a factor, you can say, or for the fire to go out if any of these factors are removed. For question B, we need to use the understanding of the fire triangle and state how the firefighting methods were used in the following examples. So for placing a heatproof mat over a beaker, this removes the air and oxygen. For using water, this removes the heat. And finally, for cutting down trees, this removes the fuel. For question C, the answer was water, for a water fire extinguisher not to be used. This is because oil and water don't mix, and if they don't mix, it will not put out the fire. And for question D, we need to write an account for your understanding of the fire triangle and used in firefighting. The answer should explain how the fire triangle gives rise to 3 different methods of firefighting and give an example for each. As per usual for long answer questions, I like to jot down little keynotes. So if I understand the fire triangle, you need to say about the fuel, the heat and the oxygen required for a fire, or saying that removing one of these will put these out. And for different methods, you can remove the heat, remove the air, or remove the fuel. And for the examples, you can say about house fires, chip pan fires, natural gas fires. All of these can be used in your answers. So an example answer would be, the fire triangle refers to the factors needed for a fire, which are fuel, heat, and air, or oxygen. Firefighting methods include removing any of the factors from the triangle. Heat can be removed by water, which is used in house fires or bonfires. Air is removed by fire blankets, foam, and CO2. Fuel can be removed by a gas supply switch off or fire break, which is used for the forest fires. So any of these examples, you'll get all 6 marks. Question 9a, we give the chemical name of the polymer represented by the diagram. So from the diagram, you can see there are 2 carbons and 4 fluorines. So this must get ethane in your mind somewhere. Therefore, this is going to be polytetrafluoroethene, as an ethene gets in the polymer. Or you could say PTFE as a little abbreviation. For II, we need to complete the equation for the production of polypropylene and name the type of polymerization. So as you can see from the diagram in the question, it already has a double bond, but we know in polymerization the double bond goes, the double bond breaks, and this is what attaches polypropylene monomers together. So this is what should be on the right-hand side of the arrow. Basically looking like the same thing, but the double bond goes because the double bond breaks, and arrows coming out of brackets. So you should have CH3 on the top left as the same in the diagram, which is bonded to a CH and which is then bonded to CH2, and then 2 lines which represent bonding to other polypropylene monomers. So the type of polymerization this is addition polymerization. This is because the double bond breaks, and this is what attaches to other polypropylene monomers. So for question B, we know that there are thermoplastics and thermosets, and we need to give one similarity and one difference. So with this, we need to think about the different types of bonding that's involved between the layers. So a similarity is both long or large molecules, so they are long chains of carbon atoms. However, there is a difference that thermosets have cross-linking strong bonds between chains, or you could say that thermoplastics have weak bonds between chains. I'm going to explain the process of addition and polymerization, which includes examples. So addition polymerization involves the joint of monomers, and you can use examples like ethene and PVC. So for the first part of your answer, you want to discuss what happens. So in this example, I use ethene. So you can say that ethene monomers contain carbon-carbon double bonds. These double bonds open up where ethene monomers can join together, and as a result, long-chain polymers are formed. In the second part, you want to include a balanced symbol equation showing the repeating unit. So for ethene, this is N-ethene, because you want to show the monomer, and this goes to the polymer as seen on the right where the double bond has broken. So if you mention all these points with similar examples, you should get all the marks. 10AI, we give the balanced symbol equation for the reaction between ethene and bromine. So ethene is C2H4 and bromine is Br2. And as a result, this gives C2H4Br2. So let's check that everything's balanced. On the left-hand side, we have 2 carbons, 4 hydrogens, and 4 bromines. And on the right, we have 2 carbons, 4 hydrogens, and 2 bromines. So we don't need to add any numbers, and everything is balanced. So for anyone's information, this is an electrophilic type of reaction, and if you continue with A-level chemistry, you'll learn all about this. So for AI, we describe the observation made during this experiment. So when you add bromine water, the orange solution goes colourless. An important point to know is that the bromine water solution goes colourless, not the alkene. So yeah, when you add the bromine water, that solution should go colourless. So for question B, it's just like before, so we need to give an equation for the polymerization of ethene and why this occurs. So this is the symbol equation, so we have n lots of ethene, so your monomer, and this goes to your polyethene. So as you can see that the carbon-carbon double bond breaks, and you put square brackets around this with bonds going out to show part of the polymer. So for the little written bit, you need to say that the double bond breaks in ethene, you get 1 mark for that, and large number of molecules, the monomers, join together to form long-chain polymers. So as you can see, I've made the keywords in green, and these are the keywords you need to show in your answer. So for BII, polymerization requires the use of a catalyst. We need to explain the effect of catalysts on the chemical reaction. So a catalyst speeds up the rate of reaction. They reduce the activation energy, and they reduce the activation energy. They do this by reducing the energy required for collisions to be successful, or you could have said they reduce the activation energy. So for part C, we need to use the table and name the 2 types of plastics involved and explain the different observation in terms of the bonding present. So A has to be a thermoplastic, thermosoftening plastic, because as you can see, when you add heat, the plastic softens. And plastic B has to be a thermoset plastic, as the plastic does not set but turns black if overheated. So you can say that weak or no bonds between chains in A, because A is a thermoplastic or thermosoftening plastic, and therefore you can also say that bonds are formed between chains in B. This means chains of A can move over one another, or you can say that chains of B cannot move over one another. So as you can think about it, so chain A, there aren't many interactions between the chains, therefore they can go over one another. And for B, so the thermoset, there are bonds between the polymer chains and they cannot travel over one another. For question 11a, we need to calculate the energy given out in burning 1 gram of butanol. So from the question, you're given the following equation. Energy given out equals mass of water times 4.2 times the temperature change. So the mass of water is 100 because it says in the question, times by 4.2 times 30. The temperature change is 30 because it says in the row of butanol under temperature change in degrees Celsius. Therefore, multiplying these all together, you'll get 12,600 joules per gram. So for part B, we need to give one other step that should be taken to ensure a fair test. So you could have got a mark for saying any of these. So you could have said the same height between flame and can, use the same wick or spirit burner, not using lids for alcohols, or changing the water each time. So for part C, we need to compare the experimental and theoretical values and give the main reason for the difference between them. So the theoretical values are greater than the experimental values, and both values increase down the alcohol group. And the reason they are different is because there would have been different heat loss to the surroundings. And finally, for part D, some people are opposed to large-scale use of bioethanol as fuel. Describe briefly why someone can take this view. So it depends on what way you want to take this. So there are two different examples you could have said. So biofuels have lower energy output than traditional fuels and therefore consume greater quantities in order to produce the same amount of energy. Or you could have said uses land that would have been used for crops and therefore leads to food shortages and price rises. So you could have either talked about the biofuel itself or the effect of the biofuel on other people. Thank you for listening.